So today's class we are going to discuss why the electric field inside a conductor is zero. So what we are going to discuss? Why the electric field inside a conductor is zero. Why the electric field is inside a conductor is zero. So before addressing this question, we will know the basic concept of what is a conductor. So conductor are those type of material which carry or conduct the electricity easily. So the material which carry or conduct the electricity easily. So what are the example of the conducting material? You can take the day-to-day life example, that is copper wire. You can use in case of a house wiring. In case of copper wire you can use the silver wire, that is silver argentinum, or you can use the you cannot use the gold wire as in case of wiring, but gold is a conductor also. So gold, Fe. So this type of material that can easily conduct the electricity. So before going to the why this electric field is zero, so we can also go to the what are the composition or how the conductor is made. So definitely conducting material or any type of material that will be made up of atom, and in case of classical theory, that is inside an atom there is a heavy nucleus. Nucleus is consist of proton and neutron, and outside there are electrons. So the mass of the nucleus is much more high than the mass of the electron. So these are classical theory. We are not going to quantum theory, because for the simplicity we can stay on the Bohr's model of atom, and it will be good approximation, and it will be give the good result in case of current and electricity. So the atom is made up of nucleus, and outside there is a electrons are revolving around this. So first case we can take that case number 1. If we take the case of electrostatic, it means the charge are at rest. Charge are at rest. Charge means there is a free charge. There is a two type of charge are there. There is bound charge and free charge. Actually the free charge or the valence electron consisting of valence electron charge, that will be conduct the electricity, and the bound charge always stay there, that they do not move. So the free charge are at rest. Electrostatic, the free charge are at rest and does not move. But if the electric field is not zero, then the charge will be moved. Charge will be moved due to the force acting on the charge. So how much force if the charge is Q and it is in the electric field of E, if it is in the electric field in the region of electric field of E, then the net force act on this charge F is some Q times electric field. So if the electric field is not zero, then the charge will be moved, and the condition will be no more electrostatic. So this is one of the explanation that in case of conductor material the electric field is zero in case of electrostatic. But this explanation is not a good or satisfactory explanation. It is not a satisfactory explanation. It is not a satisfactory explanation and valid only in case of electrostatic. Valid only in case of electrostatic. So we will go more generalization to know what is the concept or what is the reason behind why the electric field is zero inside a conductor. So more generalization, let we apply the electric field inside a conducting material. So due to application of electric field, the electron will be moved towards one plate, and the nucleus or the nucleus will be moved, or the positive charge will be moved towards another side. So in figure we can show that if the application of electric field one side, there is a positive charge will be stay here, and negative charge will be there. Basically, by the application of electric field, the force will be act on this charge and they will be separate. In atom there is positive and negative charge and they will be separate. Actually the electron will be moved and the nucleus will be stay at rest uh, practically, as the nucleus is very heavy in comparison to the electron. So the electric field direction will be from positive to negative. So the electric field direction is E. But if the conducting material is there will be some induced electric field will be created along the two sides. There will be negative charge will be created and another opposite there will be positive charge will be created. So this type of charge separation will be create a induced charge, that is E0 inside the conducting material, and the direction will be just opposite to the direction of outside electric field, as the electric field direction is always from positive charge to the negative charge. So in this region, that is inside region, you can simply say that E0 magnitude is same as the E magnitude, that is applied electric field is same as the induced electric field. Hence the net electric field E net is equal to 0 for conducting material. So this is one type of a satisfactory explanation while there is electric field inside the conducting material is 0. Another mathematical explanation is there. From Gauss law we can know that the total charge enclosed inside the material, that will be is equal to total electric line passes through that surface. So this is Q enclosed divided by epsilon naught. So the total electric flux linked through a closed surface is equal to the 1 by epsilon times the charge enclosed. So in integral form this form is there. In differential form, that is divergence of E is equal to rho by epsilon naught, where rho is the total charge density, total volume charge density. Total volume charge density. As inside the conducting material there is a net amount of positive charge is exactly same as the net amount of negative charge. So the total charge density is 0. So net total charge density is 0, as there is a same amount of positive charge and same amount of negative charge, so it will be exactly cancel each other. So divergence of E equal to 0, so this will be leads to E must be 0, electric field must be 0. So this is one of the mathematical explanation from the Gauss law of electrostatic. Another explanation can be drawn from the equipotential surface, as the conducting surface or conductor material surface is always equipotential. Let the 2 point A and B are there inside a conductor. So this point is A and this is B, and potential at that point is VA and potential at the point is VB. So we can write that VA minus VB is equal to integral of A to B E dot dl. dl is the length between the 2 point A and B. So this will be definitely equipotential surface, this is 0. So we can write that Vm is equal to Vb. So electric field E must be 0 for equipotential surface, so the electric field must be 0. So one of the common type of example that we can feel in the day-to-day life, that if there is a lightning is occurring and there is two option you have. One is there is a tree, big tree, and another is you are inside the car. Then which option you have to be prefer? Definitely we will be stay inside the car, because as it is a surface is equipotential. If there is will be lightning occur, then the lightning will be not pass inside the car, as it is a equipotential surface, and it will be act as a cage, and it is a it has no risk to be stay inside the car. If you have to be stay inside the stay under the tree, then it will be lightning will pass through your body, so you must stay inside the car. You may ask why the charge are always on the surface of the why there is a charge are always on the surface of a conducting material. So this concept can be addressed taking an example of a spherical conductor. If you take a spherical conductor, it is a sphere type of conductor, then the potential energy will be, if the charges are distributed over the surface, if the total charge is distributed over the surface case, then potential energy E surface is written as Q by 8 pi epsilon naught R. This type of potential energy you can observe. And if the charge is distributed over its volume, inside the volume is charge is distributed, then the total potential energy you can write that 3 by 20 pi epsilon naught R divided by Q square. One term is missing, it is also Q square. Okay, then the surface, if the charge is distributed over the surface, then and potential energy is Q square by 8 pi epsilon naught R, and if it is distributed over the volume, then 3 by 20 Q square by pi epsilon naught R. So you can see that from the expression E surface is less than 3 by less than E volume. So E surface is always less than E volume. So you can see that you can explain this type of concept using one of the very basic fundamental day-to-day life experience, that is, if you stand like 5 hours continuously, then you can feel tired, and if you place, if you sleep on a bed in this position for a long time, you can feel a comfort. So in this case the potential energy is minimum, and in this case your potential energy is maximum. This type of concept also explain if you have two type of configuration, one is downward parabola and there is a upward parabola, and you place two ball at this position, then it will be definitely come to the ground to attain the minimum potential energy, and it will be attracted due to the earth gravitational force, and with it will be come to the surface with a constant acceleration, that is small g. This in the case 1 also we can write that it is case 1 and it is case 2. In case 1 also it will become this mean position. So every system will try to attain the minimum potential energy. So in this above case also, in electrical system or electrostatic system also, it will be also try to attain the minimum potential energy. So the charge that will be reside on the surface will be attain the minimum potential energy. So in the case of conducting material, the charges are always reside outside the surface and distributed over its surface. Okay, and another one of the important concept is there. If there is a conducting material is there, it is a one type of conducting material, then inside there will be, if at a point if there is a charge q, it has two component, one component electric field. If there is a electric field due to a charge u1, then it has two component, one is parallel component and another is perpendicular component. So the combination of all these charge, parallel and perpendicular component will be cancelled, and outside there will be a perpendicular component is there. So the electric field inside is net electric field is 0, and outside that perpendicular component is there. So perpendicular to the surface cannot flow, and since the surface is conducting, so inside is 0 and only outside there will be a tangential component which is there. So this is a perpendicular component or tangential component is there outside the surface. Okay, so this discussion clarify your doubt that why the electric field inside the conductor is 0, and why there is always a charge will be reside on the surface even though there is a volume even there is a big surface or any volumetric surface, but this volume will be no use and it will be always on reside on the surface due to attain the minimum potential energy in case of the conductor material. Okay, thank you.